Okay, finding the Laplace transform of t squared. Here's our integral. And we start off with exactly the same dv. And I forgot to write the dt in my dv. It's important to write that. So it acts just like the previous one. But what we're going to get here is negative t squared e to the negative st over s, evaluated from 0 to infinity. And let's write it out with all the signs, and then we'll change negatives to pluses where it's appropriate. We're going to have negative the integral of what? Well, du is going to be 2t, so we're going to have 2t, and then we're going to have times negative e to the negative st over s dt. Now, this negative is going to make it a positive. This negative is going to make it a positive. Of course, the integral goes from 0 to infinity. Okay? Well, this is just let me put this into a form that you probably wouldn't have. If you factor out the 2 over s, this is just a Laplace transform of t, right? So we don't have to do the next substitution, do we? We could, and we would come out with exactly the same thing. But that's 2 over s multiplied by 1 over s squared. Which is 2 over s cubed. So let's follow the pattern and see if you can get the Laplace transform of t cubed. You only have to do one integration by parts. And you see that if you let u equal t cubed, your integral is going to be a multiple of t squared, right? At least this term of the integral is going to be a multiple of t squared. It's going to be a constant multiple of t squared. You've already got the Laplace transform for t squared.